So your task today is going to be to put all of these fractions on the number line to decide which of these intervals each of these fractions goes into. There's a lot of fractions here. It can seem a little bit overwhelming, but the first thing I want you to do is just step back and say, what do I notice about these fractions? Think about that for a moment. Maybe tell a partner something you notice. Okay, what do you notice? Let's hear some things. Okay, yep. So some of the fractions are positive and some of them are negative. That's a good thing to notice. How do you know which ones are negative? Yeah, it's not a trick question. The ones with the negative sign in front of them are negative, and the other ones are positive. We could write a plus sign there, but we just understand that the ones without a negative sign are positive. Great. What else did you notice? Okay, there are only two mixed numbers. What's a mixed number? Remind us. Yeah, so a mixed number has a whole number part and a fraction part that are kind of written together. And it's like thinking about the sum of that whole number and that fraction part. So where are the mixed numbers? Where are the mixed numbers here? Yeah, over here on the side, right? So we have 1 and 5/12 and -1 and 1/3. They kind of stick out because they're the only mixed numbers, right? I agree. Anything else you noticed? All right. Yeah, that's an interesting observation. So you're saying some fractions have numerators and denominators that are close together, while other ones have numerators and denominators that are farther apart. Did I write that down right? Okay, can you tell me more about what you mean by that? Oh, I see. Okay, so you're looking at examples like 1/5, and there the 1 and the 5 are actually pretty far apart, especially when you compare to something like 4/5 when 4 and 5 are pretty close together. Yeah, I think that's important to notice too. So I'm going to write your examples on our list just so we remember what your observations mean. All right, so there's lots more interesting things we could notice about the fractions, but the thing I want you to think about next is how could you use the things you've noticed to help you get started on that problem of putting all those fractions on the number line? How could these noticings help us get started? So let's think about those mixed numbers first. So we know we've got these two mixed numbers. How could we use what we know about mixed numbers to help us decide where these numbers go on the number line? Well, for the first one, 1 and 5/12, we said a mixed number is the sum of that whole number and the fraction. So we can think of this as 1 plus 5/12. And so what does that mean about its relationship to 1? Is it greater than 1 or less than 1? Yeah, we're adding something on to 1, so we know it's going to be greater than 1, and it's going to go in the interval, we think, maybe between 1 and 1 1/2. But we have to check, what about 1 1/2? Is it greater than 1 1/2 or less? Who has a strategy for thinking about that? Oh. Yeah, I think I see what you mean. So you're thinking just about the 5/12 part right now, right? And you said, well, I know that 1/2 is actually equal to 6/12. But we're only thinking about 5/12. That's actually 1/12 less than 1/2, right? So we know 5/12 is less than 1/2. And so when we go back to thinking about our mixed number, 1 and 5/12 is going to be less than 1 1/2. Yes, I agree. So that means we can put this mixed number into this interval. Okay, what about our other mixed number? We have -1 and 1/3. We think about that in a similar way. Well, we know it's going to be somewhere close to -1 because of that first part of the number, right? But is it going to be greater than -1 or less than -1? going to be a little tricky to think about with negative numbers, but if we think about their absolute value or their distance from 0, I think that can help. So the absolute value of negative 1 1/3 is what? Yeah, 1 1/3. So it's going to be a total distance of 1 1/3 units from 0. And we know we're going to go toward the negative numbers. So 1 unit from 0 would put us at negative 1, but we know it's a little farther. That extra 1/3 unit is going to take us a little farther. So what does that mean? Is it more than negative 1 or less than negative 1? Yeah, it's actually less than negative 1. All right, what about negative 1 1/2? Is it more or less than negative 1 1/2? Yeah, we only had to go another 1/3 unit past that negative 1, and that's not as far as a half unit would take us to get to negative 1 1/2. So we end up in this interval between negative 1 1/2 and negative 1. So we can place that one as well. Great, so just based on what we know about mixed numbers, we were able to get started on this problem. We used a strategy to place these two fractions. And maybe we can't use the same strategy for every fraction, but we were able to break off a piece of that problem and just solve that based on something we noticed about the fractions. So breaking a problem into parts. Have we done that before? What did we call it when we talked about breaking a problem into parts? Yeah, decomposition. It's another one of our CT practices, right? So when we do decomposition, we're breaking a complex problem into smaller parts that are easier to address. So we already started doing that here. We just said, what do we notice about these fractions? And we picked out the piece of just working on those mixed numbers, and we solved a piece of the problem. So I want you to keep using decomposition as you keep working. There's a lot of fractions here, and you may think like you don't have a strategy to place every single one of them on the number line. But I bet if you talk to your partner, you're going to come up with some strategies for some of them. So just keep going, keep track of the ones you've placed and the ones that are left, and we'll talk about how decomposition was helpful when we come back together. Thanks for sharing all those fraction comparison strategies. I think together we came up with strategies for placing all those fractions. It was great. So there's one more question I want to ask before we move on. How was using decomposition helpful when you were solving this problem? Yeah, I think I saw a lot of people doing that kind of thing. So you were kind of using it to keep track of what you've done and what was left to do. So for example, you were checking off those mixed numbers because we did them together. And then you moved on to thinking about those unit fractions because you thought I had a strategy for thinking about how close they'd be to 0. And you just kind of checked off so you could tell what was still left to do and what you had already accomplished. I think that's great. What else? How else was decomposition helpful? Oh, that's interesting. No, I like that. I think what you're saying is sometimes you were able to use a strategy for one collection of fractions, one group of fractions, and then based on what you did, you were able to sort of build on that for other fractions. Smart. So I think what I'm hearing you say was you had a strategy for fractions like 4/5, where it was just one part away from 1. So 4/5 is just 1/5 away from 1, so you knew it'd be just a little bit less than 1. And so use that strategy for some of the fractions, but then when you were looking at what was left, you also said, oh, I think I can use a similar strategy for the negative fractions that are kind of like that. So negative 5/6 is just 1/6 away from negative 1. So you knew where to place that. Great. Using strategies you know to create new strategies for other numbers is a great idea. So I'm glad you all found decomposition helpful. Let's all keep that in mind as we come across other complex problems this year.